Hi, all of you. Hi, everyone. Hi. Good evening. Good evening, all of you. Hi. Hopefully, I am audible and visible. Hello. Um, Drishti, can you please confirm if I'm audible and visible or any of you in the chat? Hi. Okay. Yes? France. Slightly late. No, I had told 9 p.m. na, so it's 9 p.m. only. Okay. So let's get started with the chapter now. एक तो पहले सबसे पहले basic idea that what will happen is carbon and its compounds. Comparatively कुछ students को ये chapter थोड़ा tough लगता है, but when I was in grade 10 I literally felt that this was the most easiest one. We will not speak about other platforms as of now. Acha, now coming back. So, this carbon chapter, if anybody is finding it to be difficult, then make sure that all of you will follow these notes which will be given in class, as in, it will not be a ready-made notes. Breakfast, this is not breakfast ka time. Organic nahi ho raha. Okay, Samad. I think I should stop reading the chat and I should concentrate over here. So, speaking about this, the carbon and its compounds chapter we'll be focusing in. So, whatever experienced I have, either from the EdTech platform or in school or from correcting board papers, I'll try that we can understand some topics better. Speaking about carbon and its compounds, this element carbon, if we try to take a look around whatever we are having, जैसे अगर speak of plastic or human body or the air around us or any specific substance which you have, be it hairs or DNA, all of these have carbon into it. So अगर आसपास जितनी substances हैं, all of these are having carbon. So is it the most abundant element? No, even though it is present in majority of the things around us, still it is not the most abundant element. Carbon is the 15th most abundant element on the earth's crust. Also, speaking about this element carbon, where can you find around yourselves? In grade 8 you all have studied about natural gas. तो जब आपने नेचुरल गैस के बारे में पढ़ा था या फिर पेट्रोल डीजल एंड ऑल ऑफ दीज थिंग्स, वहां पे वन थिंग वाज प्रिटी श्योर दैट वी यूज्ड अ टर्म व्हिच वाज हाइड्रोकार्बन, राइट? तो ये जो हाइड्रोकार्बन का टर्म यूज हुआ था या फिर ये जो वर्ड यूज हुआ, द वर्ड हाइड्रोकार्बन मीन्स मेड अप ऑफ टू एलिमेंट्स. नाउ व्हाट कैन बी दोज टू एलिमेंट्स? हाइड्रोजन एंड कार्बन. ये हो गया हाइड्रोकार्बन. So when you speak about food, clothes, medicines, all of these have carbon into it. और ये जो सारी चीजें हैं like these CNG, petrol, diesel, these are also having carbon into it because ये सारे hydrocarbons हैं. The amount of it will differ. It's not that each and everything which is present will have the same quantity of hydrogen. Amount will differ. Okay, so be it the carbonates, like suppose speaking of calcium carbonate limestone, or speaking about bicarbonates like baking soda to sabke ghar pe hoga. So Na8CO3, all of these things have carbon content into it. Now, we will later classify this into organic, inorganic, we will see that as well. But one more thing, speaking about carbon's content, our atmosphere has so much of carbon dioxide, 0.03%, even though it's less, but ठीक है, वहाँ पे भी है. And human body has around 18.5% of carbon present in our body as well. Chalo. Now directly we will classify the carbon compounds into two types. One will be organic, the other will be inorganic. ठीक है? Now, ये जो कार्बन कंपाउंड्स हैं, व्हेन वी आर सेइंग ऑर्गेनिक एंड इनऑर्गेनिक, सो व्हाट इज द बेसिक डिफरेंस बिटवीन देम? सो द बेसिक डिफरेंस बिटवीन ऑर्गेनिक एंड इनऑर्गेनिक इज द सोर्स वेयर यू आर गेटिंग इट. अगर सपोज आपको कोई भी सब्सटेंस अर्थ क्रस्ट से डायरेक्टली मिल रहा है, स्पीकिंग अबाउट कैल्शियम कार्बोनेट और मैग्नीशियम कार्बोनेट, these rocks kind of things which you are getting, limestone, dolomite, directly you are getting from the earth's crust. So you are actually getting it from a non-living source. Now in typical layman's voice हम बोल सकते हैं कि organs तो living things में ही होता है, so organic organs. So actually वो बोलते हैं persisting to life. Organic chemistry, when we say pertaining to life. तो ऑर्गेनिक कंपाउंड्स आर द वंस जो आपको लिविंग सोर्सेस से मिल सकते हैं. जैसे वन ऑफ द वेरी कॉमन थिंग्स विच वी मस्ट हैव फेस्ड, या अभी भी सम ऑफ अस फेस, इज एंट बाइट, राइट? और कार एसिड्स बेसिस एंड सॉल्ट में सबने पढ़ा हुआ है कि एंट बाइट में यू हैव दिस स्पेसिफिक कंपाउंड, फॉर्मिक एसिड. So this is something which you are getting from a living thing as well. So these compounds we are considering them to be as organic compounds because आपको ये मिल रहा है living component से या living things से. So the difference of organic and inorganic lies in the source where you're getting it, whether or not you are getting it from a living component या फिर inorganic component. A few common things जहाँ पे आप गलती करते हो. कार्बन डाइऑक्साइड इनऑर्गेनिक होगा, एंड कार्बन डाइऑक्साइड एंड वाटर के कॉम्बिनेशन से जो एसिड बनेगा H2CO3, ये भी इनऑर्गेनिक होगा. दीज आर द टू कॉमन थिंग्स जहाँ पे गलती होती है, मेनली H2CO3. ये कोक, लाइम, सोडा वाटर, इसमें जो एसिड होता है कार्बोनिक एसिड, दिस इज एन इनऑर्गेनिक कंपाउंड. प्लीज डोंट कंसिडर इट एज ऑर्गेनिक. उसके अलावा मेजॉरिटी ऑफ हाइड्रोकार्बन्स आप जो देखोगे वो ऑर्गेनिक कंपाउंड ही होगा. बिकॉज कार्बोनिक एसिड तो आपको रेन वाटर में भी मिल जाता है, राइट? यू गेट इट फ्रॉम रेन वाटर एज वेल. गुड इवनिंग टू ऑल ऑफ यू हु हैव जॉइन्ड नाउ एंड हु हैव रिटन हाय और हेलो. या फिर अब तो I should say bonsoir, maybe. Okay, now the most important topic which we are about to discuss today is bonding in carbon. अब देखो, frankly speaking, आप जब एनसीईआरटी बुक खोलोगे, ये एक बेसिक सा आपको इंट्रोडक्शन मिलेगा. ये डायरेक्टली एनसीईआरटी का ही कॉपी पेस्ट मिलेगा आपको यहाँ पे कुछ लाइंस. एंड पर्पसली आई हैव रिटन दैट, yes, mild acid area. Now purposely I have written it from your NCERT only क्योंकि NCERT is your Gita Bible, everything for your board exams, right? So make sure that if you see these terms frequently, अगर आप यहाँ पे देख रहे हो, फिर से बुक में पढ़ रहे हो, थोड़ा easy होगा हम लोगों के लिए. अच्छा, now bonding in carbon, ये सबसे important topic होगा आज का. This is most important. So carefully, let's proceed forward. Bonding in carbon में first understand that why it has to. Metal and non-metal chapter, when you studied this metals and non-metals chapter, which was I think barely 1 month back, तो वहाँ पे you studied something which was called as ionic bond या ionic bonding. Ionic bond में you got to know that metals are the ones which will donate their electrons to the non-metals. तो metals were completely transferring their electrons to non-metals. ये तब possible था when you had a donor of electron and you had one acceptor of electron. So non-metals were acceptors of electrons और जो metals थे ये थे donors of electrons. But the question is कि ये bonding होता क्यों था? So you got to know even in the third chapter कि ये जो सारे elements हैं ना, these all are in a rush to attain a configuration like those of the noble gases. वो जो कुछ ideal cousins होते हैं ना, जिनकी वजह से डांट पड़ती है. I also have some in सरकारी नौकरी. Okay, so when you're compared that, okay, try and become like. So these metals, like suppose sodium, 2, 8 and 1. This wants to become like neon. तो ये कैसे बनेगा? It wants to lose this electron or donate this electron or give away this electron. Or chlorine, or suppose we speak of hydrogen, which wants to become like helium, which will have a configuration of 2, can become so if it can accept one electron. तो अगर suppose हाइड्रोजन के पास एक सोडियम आ जाए, it's like all life set, all done. Hydrogen will happily take away the electron, it will become like helium. Sodium बन जाएगा donor, and in this way a positive ion, negative ion will be formed, all will be set. But the problem is, what if it's only hydrogen which is sitting and waiting, that if somebody could come and give away one electron? So if there is a room, imagine a room jahan pe you have only and only hydrogen. If you have only and only hydrogen, is there any element over here which is, or any atom over here which is ready to give away an electron? No. यहाँ पे कोई भी इलेक्ट्रॉन देने के लिए रेडी नहीं है. Okay, nobody is going to give away electrons here. So ultimately what will happen, they will try to manage on their own. और ये एक बहुत common scenario है in our classes as well, especially practical file when you people were told to write. तो practical file लाने में अगर suppose 40 students are there in class, I remember 3 या 4, उससे ज़्यादा नहीं, barely 3 or 4 would come, right? Barely 3 or 4 people would bring that practical file. उसके अलावा तो बाकी लोग would be like beg and borrow from others. तो अगर मान लो क्लास में extra sheet है, then somebody will lend you. But if there is nobody who has anything extra, there's no ways you can like snatch. कुछ लोग तो वो भी करते हैं, but you should not. So if suppose a project activity is going on where nobody is having anything extra, then sharing has to be done, right? So hydrogen will be sharing electrons in this case, and the type of bond will be called as covalent bond. तो सबसे पहले ये covalent bond क्यों कार्बन करेगा, we will see this as well. ये थोड़ा important है, we will see this section as well. But एक बार basic covalent bond है क्या वो देख लेते हैं, फिर we will see this as well. Okay, now speaking about this one. So if only hydrogen is there, so two hydrogen atoms, if they come nearby, so imagine this is your table in which two people are supposed to sit. So if both of these keep one electron in the center, and in such a way that both of them are using it equally, equal distribution हो रहा है, if suppose, then what will happen, एक molecule form होगा और एक friend का group form हो जाएगा, which will be hydrogen molecule in this case. Now Lewis dot structure, if you remember, वहां पे you had to show only valence electron, right? Only valence electron या सिर्फ last shell के electron को show करना होता था. इलेक्ट्रॉन डॉट स्ट्रक्चर बोलो या लुईस डॉट स्ट्रक्चर बोलो, दोनों सेम है, चलेगा. नाउ इन दिस केस अगर आप हाइड्रोजन का इलेक्ट्रॉन डॉट स्ट्रक्चर देखो, ओनली वन इलेक्ट्रॉन इज देयर. कभी कभी इस कोवैलेंट बॉन्ड को शो करने के लिए वी यूज सम सर्कल्स. वो कब और कैसे, if I do it like this, or if I am writing it like this, I'll just show you किस पे full marks मिलता है, even though all looks different. Or if suppose I am writing it in this way, all of these will give you full marks. ये जो circles है ना, if you're confident enough only then you do. If you're not confident enough मत बनाओ. बोर्ड में ये circles नहीं बनाने के लिए marks deduct नहीं होता है. So if suppose you're not doing it and the marks is not getting deducted, risk mat lo if you're not confident. But then why we do it? It gives a better clarity. जैसे set theory में maths का होता है ना कि एक common to both zone आता है. It's like an overlap. One hydrogen atom, another hydrogen atom, ये एक overlap का zone होगा. And in that zone you will have both the electrons kept over there. तो यहाँ पे sharing of electron होगा, due to which both the hydrogen atoms will now have access to 2 electrons each. And this type of bonding, okay, the other one was not visible. Yes, electron dot diagram, I'm drawing it here. So this kind of diagram with the circles as well is allowed, but I'll suggest mat banao isko. Okay, I mean, you can skip if you are not confident. So understand one thing कि covalent bond का मतलब है sharing of electron. Now the question is, carbon को ये sharing of electron क्यों करना पड़ा? Why carbon had to go for covalent bonding and not ionic bonding? द टर्म आयनिक बॉन्ड जब हमने डिस्कस किया वहां पे एक चीज फिक्स्ड था दैट गेन और लॉस ऑफ इलेक्ट्रॉन हैड टू टेक प्लेस तो दिस is carbon. The electronic configuration of carbon, if you people remember, is, please write in the chat as well, it is 2 comma 4, right? And carbon is having two distant cousins who are very successful. One is helium, which is 2, the other is neon, which is 2 comma 8. So somehow carbon has a wish that I wish I can become like those. So if suppose carbon को helium की तरह बनना है, it will have to lose, so minus 4 electrons. E minus का मतलब electron, minus 4E minus मतलब removing 4 electrons. तो ऐसे क्या बनेगा? C4 plus. अब एक बार C4 plus का condition check करो. 6 positive particles or 6 protons with only and only 2 electrons. Now understand one thing कि कभी भी अगर you are trying to take out an electron from an atom में क्या है आपका positive nucleus है and then you have these shells around and you have electrons. तो अगर आपको इलेक्ट्रॉन रिमूव करना है एक बॉन्ड है एक फोर्स ऑफ अट्रैक्शन है आपको उसको ब्रेक करके लेके आना है सो यू विल रिक्वायर एनर्जी. तो अंडरस्टैंड वन थिंग कि रिमूविंग ऑफ इलेक्ट्रॉन्स नीड्स और रिक्वायर्स एनर्जी. ठीक है इलेक्ट्रॉन रिमूव करने में एनर्जी चाहिए. यू आर ट्राइंग टू रिमूव 4 इलेक्ट्रॉन्स सो अमाउंट ऑफ एनर्जी रिक्वायर्ड दिस इज very high. So energy required becomes very high, so much so that chemical reactions cannot suffice. So itna zyada energy chemical reactions are not providing. So this process of formation of C4 minus C4 positive by losing 4 electrons not allowed. On the other hand, अगर suppose it wants to become like neon तो ये 4 electrons gain कर सकता है plus 4 electrons. अगर 4 electrons gain हो रहा है then क्या होगा C4 minus. अब this I always compare to a classroom situation with 6 positive particles and 10 negative particles. और कभी कभी ये सबने face किया है be it student or teacher कि आप कितना भी बोल लो these 6 positive particles will try to control these but वो नहीं होगा. वो होता है ना condition when the teacher just walks out of the class कि चलो मेरा हो गया. I think it happened with me also once or twice. चलो now so this 6 positive and 10 negative ये बहुत ज़्यादा मुश्किल होगा to manage. Energy required becomes high Aryan because 4 electrons you are trying to remove. Okay, also देखो when you removed your first electron C plus बना already positive है जो already positive है उससे आप electron snatch करोगे so और ज़्यादा energy लगेगा compared to the first step. यहां से जब आप एक इलेक्ट्रॉन रिमूव करोगे C+2 बनेगा. इट्स इवन मोर पॉजिटिव जो ऑलरेडी 2 पॉजिटिव चार्ज से है आप उससे एक और इलेक्ट्रॉन लेके आओगे सो दैट विल बी इवन मोर डिफिकल्ट. तो एनर्जी रिमूवल हर स्टेप में इंक्रीज होते जाएगा और अल्टीमेटली इट बिकम्स वेरी हाई. ठीक है. Now, moving towards this neon which we were speaking, that is C4 minus का जब form करना है, only 6 positive, 10 negative, ये जो condition है ये बहुत ज़्यादा unstable हो जाता है. So since this ion is highly unstable, this will also not be formed. Yes, you are agree that very unstable. Ritz Arts ने लिखा है, नाम लिख दो. Okay, now. बॉन्डिंग इन कार्बन जो डायरेक्टली आपकी एनसीईआरटी बुक में है जस्ट सी दैट सेक्शन. इट कुड गेन 4 electrons forming C4 minus ion but it would be difficult for the nucleus with 6 protons to hold 10 electrons. तो न्यूक्लियस के पास है 6 पॉजिटिव पार्टिकल्स और 10 इलेक्ट्रॉन्स अगर आएगा डिफिकल्ट होगा न्यूक्लियस के लिए जिसके लिए वी यूज द टर्म अनस्टेबल हो जाएगा. On the other hand, when you speak about the other one, that is forming C4 plus ion. इस केस में energy required to remove electron will be very high. That's why chemical reactions में rhythm. Okay, rhythm. So that's why this is also not being formed. Okay. Now, तो ये हो गया that carbon is not allowed to form C4 plus, not allowed to form C4 minus. So now the question is, so what will carbon do? You are neither allowing it to gain electron, nor are you allowing it to lose electron. In that condition, कार्बन विल स्टार्ट शेयरिंग. तो अब देखते हैं कार्बन का एक एग्जाम्पल ऑफ शेयरिंग इलेक्ट्रॉन वाया मीथेन फॉर्मेशन. ठीक है. नाउ आफ्टर दैट वी विल सी हाइड्रोजन, ऑक्सीजन, नाइट्रोजन, जो पूरा एनसीईआरटी बुक में डायग्राम्स है ना, वो भी चेक करेंगे. बट एक बार पहले कार्बन का शेयरिंग देखते हैं. हाय सार्थक. ओके, नाउ this is your carbon element. Carbon's electronic configuration is 2, 4. So last shell में there will be 4 electrons. अब एक और चीज है जो देख लो. Electrons को you can show either by cross or by hollow sphere or by solid sphere. ये तीन में से आप कुछ भी यूज करो, all three are allowed. इसके अलावा आई विल सजेस्ट यू कुछ और यूज मत करो. दीज थ्री आर द अलाउड नोटेशंस ऑफ इलेक्ट्रॉन. ऑल्सो वन मोर थिंग, अगर आपकी मर्जी, फॉर डिफरेंट एटम्स यू यूज द सेम नोटेशन और यू यूज द डिफरेंट नोटेशन. आई विल सजेस्ट कि आप डिफरेंट नोटेशंस यूज करो, क्योंकि आपका खुद का डायग्राम थोड़ा क्लियर रहेगा. इट विल बी क्लैरिटी फॉर यू एज वेल, जो पेपर चेक कर रहा है उसके लिए भी. ओके, नाउ hydrogen, which wants, hydrogen wished to become like helium. So hydrogen wants 1 electron. Carbon, which is 2,4, wishes to become like neon. So carbon wants 4 electrons. So ये condition देखो, nobody is ready to give away electrons. Everybody wants electrons, right? Everybody is needing electrons. So if everybody is needing electron, then what will happen? They will share. That is the only option left. Now sharing will not be like जो स्कूल में होता है ना कि one person will be like, oh, even though all of us are using, but still I am the one who will keep majority of the things on my table. ऐसा वाला, in this case it will not happen. There are other cases like HCl जहाँ पे आप देखोगे कि unequal sharing हो जाएगी. But when we speak about this specific substance, carbon and hydrogen, equal sharing होगा because of angle. That also I'll explain once. Now, hydrogen will keep 1 electron, carbon has 1 electron over here. If you check hydrogen's circle, तो hydrogen के circle में 2 electrons complete, it's all set for hydrogen. But is it all okay for carbon yet? No. Carbon wanted, carbon wanted a total of 8. अभी भी carbon के आप वो red वाले circle में देखो सिर्फ 5 electrons हैं. So it will need to bring 3 more hydrogen atoms. So 3 more hydrogen atoms will come into the picture, and this is how your methane will be completed. Now there is something balanced. There is something called as electronegativity. मतलब electrons attract करने का power. डिफरेंट एलिमेंट्स की डिफरेंट वैल्यू होती है. कार्बन और हाइड्रोजन का वैल्यू भी डिफरेंट है. नाउ द क्वेश्चन इज, अगर डिफरेंट है तो समवन और द अदर कुड हैव यूज्ड मोर ऑफ इलेक्ट्रॉन. जैसे होता है ना क्लास में, टू फ्रेंड्स आर सिटिंग बट समबडी ट्राइज टू बिहेव लाइक अ बुली एट टाइम्स. वैसा कंडीशन इन एटम्स में भी होता है. बट यहाँ पे दैट कंडीशन इज नॉट अप्लाइड. द रीजन इज, अगर सपोज यू आर स्टैंडिंग इन सेंटर, one friend is pulling your one hand from one side, दूसरा friend is trying to pull you from the other side. If both are pulling you with the exact same force, तो अगर सेम फोर्स अप्लाई होगा दोनों साइड में, अपार्ट फ्रॉम लैंडिंग अप इन हॉस्पिटल, द क्वेश्चन इज यू आर फिक्स्ड ऑन दैट पोजिशन, राइट? तो ये कार्बन के साथ इफ यू टेक अ लुक, 4 हाइड्रोजन एटम्स आर देयर, 4 डिफरेंट डायरेक्शंस में, बट एट इक्वल एंगल, and force will be equal. That's why methane में there will be totally equal sharing of electrons होगा. ओके और कोई चार्ज सेपरेशन यहाँ पे नहीं आएगा. नाउ व्हेन आई एम स्पीकिंग अबाउट दिस इक्वल शेयरिंग, एक अनइक्वल शेयरिंग ऑल्सो आई विल एक्सप्लेन, एंड वाया दैट you will recap a very important concept of acids, bases and salt. जब आपको एक क्वेश्चन आया था that HCl gas pure when it is passed through litmus paper, which is dry litmus paper, suppose dry blue litmus paper, and the question was whether or not it will change its color. तो उसके लिए आपको आंसर क्या देना था, दैट इट डज नॉट चेंज इट्स कलर, राइट. अगर ड्राई ब्लू लिटमस पेपर है, 100% HCl है, तो आपको बोलना था दैट इट डज नॉट चेंज इट्स कलर. नाउ द क्वेश्चन इज वाई, उसका रीजन अभी देखते हैं. तो क्लोरीन के लास्ट शेल में होते हैं अ टोटल ऑफ 7 इलेक्ट्रॉन्स, 1 2 3 4 5 6 and 7. तो क्लोरीन की इलेक्ट्रॉनिक कॉन्फ़िगरेशन विच इज दिस, इट इज सीक्रेटली विशिंग टू अटेन द कॉन्फ़िगरेशन लाइक आर्गन. लास्ट शेल में उसको भी 8 चाहिए. हाइड्रोजन विच इज हैविंग अ कॉन्फ़िगरेशन ऑफ दिस वांट्स हीलियम, तो हाइड्रोजन को लास्ट शेल में 2 चाहिए, ड्यूप्लेट चाहिए. So hydrogen and chlorine were sharing electrons. Now technically speaking, ये दोनों electron should be placed at equal distance, right? But chlorine जो है वो ज़्यादा electronegative है. So ultimately ये जो electrons हैं which came from hydrogen side as well will be more towards chlorine. तो ये जो इलेक्ट्रॉन्स का शेयरिंग होगा ये थोड़ा अनइक्वल सा शेयरिंग होगा, बट स्टिल अभी आयंस फॉर्म नहीं हुआ है. सो दिस इज अ कोवैलेंट बॉन्ड, शेयरिंग ऑफ इलेक्ट्रॉन्स वाला बॉन्ड विच इज फॉर्म्ड. तो HCl 100% प्योर, नो आयंस. क्यों? क्योंकि इट इज कोवैलेंट बॉन्ड. ऑल्सो जब 1 इलेक्ट्रॉन फ्रॉम वन साइड, 1 इलेक्ट्रॉन फ्रॉम वन साइड, सो 1 पेयर ऑफ इलेक्ट्रॉन मिलके एक बॉन्ड बनाएगा. So we call this to be as single covalent bond. तो एक single covalent bond has been formed over there. Okay, single covalent bond form हुआ है, that's why no ions are there. Now when water will come into the picture तो क्या होगा? The moment water comes into the picture, ये इस bond को इस way में break करेगा. Ultimately हाइड्रोजन का जो इलेक्ट्रॉन था that goes away, so H plus and Cl minus. ठीक है, so this is also single covalent bond only. Now coming back towards this, so in case of methane as you see over here, ये जो भी common to both zones है ना, यहाँ पे 2 electrons present है या फिर 1 pair of electron present है. And when 1 pair of electron gets shared, we call this to be as a single covalent bond. So there are a total of 4 single covalent bonds in methane. This is again a common like error which you make in your answer sheets. आपको question आता है what is the type of bonding, आप लिख देते हो 4 bonds या tetra bond. No, there is nothing as tetra covalent bond first of all. और यहाँ पे अगर आप देखो you have to write 4 single covalent bond. Be specific with 4 single bonds. This is about your hydrogen. Okay? Hi, Assis. Now, moving next one. Preet, I think you're icse, right? तो आपने तो bonding पहले भी पढ़ी है. Now moving towards hydrogen. That what is the bonding in hydrogen? तो carbon, this hydrogen का bonding which is over here, ये देखो, ये जो दोनों hydrogen के electrons को different way में show किया हुआ है. So you are seeing that hydrogen का electron in one case it is sphere, in the other case it is a cross. If you want, you can represent it in this way as well. Agar you are drawing it in this way as well, there will be no deduction in marks. This is the Lewis structure of hydrogen. इसको भी hydrogen का Lewis structure माना जाएगा because you're showing 2 electrons in the center. But if I am showing the electron dot structure of hydrogen like this, ये गलत है because this electron is on the other side. It has to be shown in the center. Now, if I am showing the electron dot structure as this, it is correct. So when you have 10 types of doubts, which one is correct, which one is wrong, I hope this will clarify that to you. So when there is one pair of electron being shared, a single covalent bond is being formed. And so why is covalent bond being formed? या covalent bond हुआ क्या? So in order to overcome the problem कि neither gaining electron is being allowed nor losing is allowed, or suppose there is nobody to share or give away the electrons, then hoga sharing of valence electrons. And that type of bond which will be formed, we will call that to be as covalent bond. In fact, it's not only carbon, there are many other elements. For example, I'll write a few molecules here. Water, कॉमन वंस जो आपके आसपास है आपको समझ में आएगा. अमोनिया, कार्बन डाइऑक्साइड, कार्बन टेट्राक्लोराइड, मीथेन, all of these molecules, like suppose hydrogen molecule, oxygen molecule, nitrogen molecule, ये सब बना है via covalent bond या sharing of electrons. Okay. The second one is double bond. Yes. So I am just saying about covalent bond as of now. Now covalent bond will be of different types. Then we will see कि double bond, triple bond ये भी आएगा. Okay. Now we will move towards double covalent bond. Single covalent bond you have already understood. We will move towards double covalent bond now. डबल कोवैलेंट बॉन्ड का अगर एक सिंपल रियल लाइफ सिनेरियो देखो तो सबसे पहले एक चीज समझो, कोवैलेंट बॉन्ड इज अ प्रॉपर सेल्फिश बॉन्ड. कोवैलेंट बॉन्ड ऐसा नहीं है कि चलो आई वेंट टू स्कूल वन फाइन डे, आई फॉरगॉट टू टेक माय पेंसिल बैग, आई टोल्ड माय फ्रेंड दैट विल यू लेट मी यूज योर्स एंड द फ्रेंड इज लाइक या यू यूज व्हाटएवर यू वांट फ्रॉम माय पेंसिल बैग. ऐसा बिल्कुल भी नहीं है. In covalent bond, if you are telling your friend, can I use your black color pen? Your friend will be like, but you have to let me use other different colors or something or the other. So if I am letting you use one object, you have to let me use one object. If I will allow you to use a scale and a pencil, you will have to let me use two of the other objects. It's in that type. Okay. So moving towards the double covalent bond. So in double bond, the first example we will see will be of oxygen. उसके बाद carbon dioxide भी देखेंगे. Speaking about oxygen, oxygen's electronic configuration is 2,6. But oxygen is wishing to become like neon, which is 2,8. So oxygen wants 2 electrons. Now oxygen, if it is going to another oxygen atom only, then what will happen? तो oxygen के पास अपना खुद का 6 electrons है. The diagram which is shown in black color, यहाँ पे already you have all dots over there. So the other diagram I'll do with dot and cross so that both will be visible to you. So it will reach to the other oxygen atom and say, can I use 2 of your electrons? If I can do so, my octet will be complete. Let's count the electrons. 1, 2, 3, 4, 5, 6, 7 and 8. So in this way, the octet can be completed. The question is, will the other element or the other atom of oxygen allow to use those 2 electrons बस ऐसे ही free में? No. It will use 2 electrons from the other atom. So in this way, both of these will get their oxygen. Okay. Can I repeat double bond? No, you cannot. अगर आपको डबल बॉन्ड को शो करना है आप ऐसे शो नहीं कर सकते हो. You have to show it in this specific way only. Okay. Now, each line over here indicates one pair of electron. या फिर each line indicates 2 electrons. So when you're drawing 2 lines like this, it means there are total of 4 electrons या 2 pairs of electrons. So in this way, you have a double covalent bond being formed. ठीक है? So this bond over here, O2, which will be formed. So this indicates the Lewis dot structure of oxygen. ये भी correct Lewis dot structure है for oxygen, and this is your oxygen molecules representation. Okay, so O2 or oxygen molecule can be represented in this way. Moving towards the carbon dioxide molecule. अगर आप NCERT question देखो, in text question, wait, I think I had copied, yeah. What would be, ये in text question है, after the discussion of the first part आपके book में ये आता है. What would be the electron dot structure of carbon dioxide which has the formula CO2? So let's see the answer for this in text question here. Make sure you all solve the in-text questions. कभी कभी you will see sample papers में या boards में वहाँ से कुछ questions आ जाते हैं. So when teachers force you in class कि copy में in-text question नहीं है and you make that fussy face कि अरे again she came started shouting on me कि in-text question नहीं किया, net पे तो सारा कुछ available है, I'll just copy from there, don't do that. Board में आप copy तो नहीं कर पाओगे ना. So teachers अगर चिल्ला रहे हैं, there's a reason for that. Now carbon 2,4, ठीक है. तो लास्ट शेल में 4 इलेक्ट्रॉन्स, 1 2 3 4. ऑक्सीजन, now why I have distributed 2 2 on each side, क्योंकि ऑक्सीजन is coming to share इलेक्ट्रॉन और ऑक्सीजन को चाहिए 2 इलेक्ट्रॉन्स. तो अगर ऑक्सीजन wants 2 electrons, so in this way 2 2 has been distributed on each side. So one oxygen atom you can place over here, the other oxygen atom you can place over here. So what will happen? Oxygen will let carbon use 2 of its electrons and carbon will also be using in return 2 of the electrons of oxygen. So if you see the red circle here, which indicates the zone for carbon, there are all 8 electrons complete. On the other hand, if you see this specific circle here, which is for oxygen, here also you have 8 electrons, which is complete. So carbon is remaining in center, one double bond with oxygen atom here, the other double bond with the other oxygen atom here. Now, अगर आपको question है that you have to draw the electron dot structure. So if I represent it like this, do you think it is correct? Electron dot structure of carbon dioxide, ये correct है? Yes or no? No, this is wrong. For electron dot structure, you can't show the lines. इसको बोलते हैं bond line structure और ये correct representation नहीं है. So if you have to show the electron dot structure, proper distribution of electrons के through ही show करना है. So this will be the Lewis structure या फिर the electron dot structure, जो भी आप बोलो. Okay, this is exactly what you will do, not the other one. अच्छा, now we will speak about triple bond. तो single bond हो गया, double bond हो गया. Now we will speak about triple bond in case of nitrogen first and then carbon. So when you are speaking about, wait, yeah. So when you are speaking about this specific element nitrogen, जिसका electronic configuration is 2,5. So nitrogen wants 3 electrons. Now understand one thing very clearly. If nitrogen is approaching somebody that I want to use 3 of your electrons, I have 5, I want to use 3 of your electrons. Nitrogen will have to put 3 of its electrons in front to be used. So the other nitrogen atom, if I am showing it in cross in this way, it will also use 3 electrons from the other one. So in this way, अगर आप देखो ये जो common to both zone है ना, यहाँ पे you have a total of 6 electrons. Or we can say you are having 3 pairs of electrons. So when you have 3 pairs of electrons, that is when you have a triple covalent bond being formed. Okay, so this is your triple covalent bond. In short, if we have to represent, we write N, we show 3 lines over here and the other N. तो ये हो गया triple covalent bond of nitrogen. So these can be the 2 ways. ये जो 2 electrons N में show किया हुआ है, इसको show करो ना करो दोनों चलता है. We generally do it. कभी कभी अगर आप लोन पेयर सुनोगे, दिस इज द मीनिंग ऑफ इट. ठीक है, द इलेक्ट्रॉन्स विच आर नॉट इन यूज. अब we will see examples of carbon compounds with all these 3 kinds of bonds. So when we speak about types of covalent bonding, it's of three types: single bond, double bond and triple bond, right? सिंगल बॉन्ड के कार्बन कंपाउंड के एग्जाम्पल के लिए क्या देखा था? मीथेन. सो मीथेन was having a structure of this way where you had one pair of electron being shared. तो ये था single covalent bond. Now we will be moving towards double and triple covalent bond. तो इथीन, we will see in the upcoming classes कि ethene क्यों बोल रहे हैं, but as of now understand that ethene is a compound where you have 2 carbon and 4 hydrogen. अब speaking about this compound, यहाँ पे you will see a double bond. You get to draw the electron dot structure for this as well in your classes. So electron dot in your school definitely. So electron dot structure अगर बनाना है for this compound, 1 carbon in center, 2 electrons I will keep towards each carbon, because यहाँ पे देखो it's a double bond, so two electrons they will be sharing. Now the hydrogen atoms will come into the picture. Why? Because अगर आप सिर्फ कार्बन का देखोगे, the valency is still not satisfied. Each carbon is having 6 electrons even after sharing. So hydrogen particles will come and they will keep one electrons over here. So in this way, all the 4 hydrogen atoms are happily getting their duplet structure. ठीक है? तो सबका duplet मिल गया. अब कार्बन का octet कैसे हो रहा है? So carbon will be using the electron from the other carbon atom as well. So this is how both of the carbon atoms will get their octet completed. If you note, यहाँ पे दोनों कार्बन एटम के लिए मैंने एक के लिए क्रॉस यूज किया, दूसरे के लिए डॉट. अगेन इट्स योर चॉइस. सो दिस इज अ कंपाउंड. अब वी विल लाइक लेबल ऑल द बॉन्ड्स. ठीक है? यहाँ पे हाउ मेनी डबल बॉन्ड कैन यू सी? You have one double bond. And how many single bonds can you see? Exams में ना ऐसे भी questions आते हैं that in this specific molecule, how many single bonds and how many double bonds are there? So there is only one double bond, but there are 4 single covalent bonds. These kind of questions are common for your pre-boards, that you will be told a molecule or a structure you will have to draw and then you have to count the number of bonds. Okay? So ये जो हाइड्रोजन के साथ वाला बॉन्ड है, ये सारा सिंगल कोवैलेंट बॉन्ड है. सो यू हैव 4 सिंगल कोवैलेंट बॉन्ड्स एंड यू हैव 1 डबल कोवैलेंट बॉन्ड. नाउ इथाइन, इस मॉलिक्यूल में कार्बन एंड कार्बन शेयर्स 3 pairs of electrons. So if they are sharing 3 pairs of electrons, then okay, now one will be shared with hydrogen for each. So each carbon will share 1 electron with hydrogen and the other one remains as it is. So this is how you are getting a triple covalent bond. तो triple covalent bond में you are having, इस specific compound में you are having a single covalent bond on one side and this on the other side. So total 2 single covalent bonds hai. And center में over here you have a triple covalent bond. ठीक है? तो यहाँ पे you are having a triple covalent bond which is present for this carbon and carbon का bond. एक आता है क्वेश्चन फ्रॉम द डिफरेंस बिटवीन आयनिक एंड कोवैलेंट कंपाउंड, और दिस इज नॉट समथिंग आउट ऑफ सिलेबस. ये टॉपिक आपके एनसीईआरटी में भी मेंशन्ड है इन वन स्मॉल पैराग्राफ इफ यू चेक योर बुक. सो ओवर देयर फॉर आयनिक कंपाउंड्स इट इज टोल्ड दैट, wait, I think ये opposite हो गया है. या so the ones which ionize will be ionic compounds. Why? Because they already have ions in them. अगर हम सोडियम क्लोराइड की बात करें ना, it is made up of sodium ion and chloride ion always present together due to strong electrostatic force of attraction. ऑपोजिट आयंस हैं, सो क्या होगा, इनका जो फोर्स ऑफ अट्रैक्शन है बहुत स्ट्रॉन्ग होगा. ठीक है? सो इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन विच विल बी प्रिटी स्ट्रॉन्ग. Covalent bonds, it's based on sharing. You don't have opposite particles, you don't have opposite charged particles which are attracting each other. अगर आप मीथेन की बात करो तो यहाँ पे हमने कोई पॉजिटिव नेगेटिव का चार्ज डिफरेंस नहीं लिखा था. सो यहाँ पे फोर्स ऑफ अट्रैक्शन इज वीक. अगर फोर्स ऑफ अट्रैक्शन वीक है ना तो इनकी मेल्टिंग पॉइंट और बॉइलिंग पॉइंट लो हो जाती है. देयर इज वन पॉइंट मेंशन्ड इन योर बुक अबाउट कोवैलेंट कंपाउंड्स दैट दे हैव लो मेल्टिंग एंड बॉइलिंग पॉइंट. तो अगर आपको इसका रीजन पूछे दैट व्हाई दे हैव लो मेल्टिंग एंड बॉइलिंग पॉइंट, द रीजन इज वीक force of attraction. Ionic compounds will be having high melting point and high boiling point. The reason will be strong force of attraction. Now coming towards iron and not ions. So covalent bonds mein you don't have ions formed on their own. In ionic compound, they are already in ion state, right? They already have ions. So molten state mein they are good conductors. By the way, sodium chloride solid is a conductor, true or false? इसका आंसर दे देना आप लोग. सोडियम क्लोराइड सॉलिड इज अ कंडक्टर, ट्रू और फॉल्स. मूविंग टू द अदर पॉइंट, कोवैलेंट कंपाउंड्स आर पुअर कंडक्टर्स ऑफ हीट एंड इलेक्ट्रिसिटी, whereas आयनिक को गुड कंसिडर किया है बिकॉज ऑफ द प्रेजेंस ऑफ ions into it. And definitely coming back towards here, sodium chloride solid will not be a conductor because the ions are fixed in a position. You need the ions in free or mobile state if you speak about this to be a conductor. ठीक है, तो ions are fixed in a position, it's not conducting over here. Okay, now that we are done with single bond, double bond and triple bond, we will discuss the other question of your NCRT in text. तो एक तो था this one, that is carbon dioxide. The next in text question which you have over here is you have to draw the structure of sulfur. एक हिंट दिया हुआ है यहाँ पे. There is one hint given to you that 8 atoms of sulfur are joined together in the form of a ring. Now, one mathematical structure which you can imagine with 8 of these edges or particles, we can think of an octagon, right? Now, so there will be sulfur particles which will be 8 in number. They have to be arranged in this way that they are sharing electrons, and the sharing of electrons will also be single covalent bond type. Why we said single covalent bond type? क्योंकि सल्फर का इलेक्ट्रॉनिक कन्फिगरेशन अगर आप देखोगे, so it wants 2 electrons. तो अगर मान लो one sulfur atom is kept over here, the other is here and the other is here. So this sulfur atom in between, if it has 2 electrons present to share, one here, the other here, इसका तो हो जाएगा ना complete, because it already has its own 6 electrons, 2 electrons coming from the other sulfur atom. So if I draw the ring for this sulfur, इसका octet complete हो जाएगा. Okay, so we will draw the rings for all of these sulfur to cross check that whether or not it is working in the same way. So for this sulfur atom, ये हो गया इसका octet का ring. This ring looks not like a sphere, but ठीक है, चलेगा. For this sulfur atom, 1, 2, 3, 4, 5 is here, 6 is here, 1 it will share from the other, octet complete. So in this way, you will have to draw the rings for all of these sulfur. Again, one more thing, ring banana is not a compulsion. If you want, you can just write these sulfur atoms like this: 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and for this as well. Okay, so in this way, when you draw for all of the 8, you can complete it in this way as well without messing up with those rings. But since we are trying to complete for this one, I will try to complete. First of all, draw all the 6 electrons for all of it, and sharing will be single covalent bond type. एक बार जब सबका इलेक्ट्रॉन्स बन जाए, फिर रिंग्स बनाना स्टार्ट करो, और सारे रिंग्स में होंगे 8 इलेक्ट्रॉन्स. 4 will be for personal use and the other will be shared electrons, and उस shared electrons में भी 2 will be from its own side and 2 by the other atom. ठीक है, so this is how via sharing of electrons, you can get the octet for all the sulfur atoms. And this question which you have for Lewis structure, you can even draw just these electrons in order to make it less messy. अगर आप सिर्फ ये electrons भी बनाओगे तो भी it works. Okay, so you can try and you can complete the structure in this way for sulfur in this way as well. So this was it about your single, double and triple bond. So quickly just what we have done, a quick recap. So we first spoke that the element carbon, when we speak about carbon, there are many compounds of carbon all around. ये जो element carbon है इसका electronic configuration है 2,4, right? 2,4 is the electronic configuration for this element carbon. It is pretty stable. ये एक non-metal है. Valency will be 4. Earth's crust में it is 15th most abundant element. This carbon can form compounds via sharing of electrons or sharing of electrons से जो compounds बनेगा we will call it covalent bond. और ये covalent bond can either be single bond, it can be double bond, or it can be triple bond as well. We have seen examples of compounds of carbon with single bond, double bond, and triple bond. Apart from that, we have also seen the examples of compounds like hydrogen, oxygen, and nitrogen, which were respectively single, double, and triple covalent bond. ठीक है? So this was about the first part, that is bonding in carbon. इसके बाद we will come towards the versatile nature of carbon, allotropes and hydrocarbons, which maybe we can cover another day. Because इतना के बाद तो y'all stop receiving anything. This much I know very well. Okay, chalo. So I think we can stop over here. Have a great day if you're watching in the day, or have a good night. So take care, all of you. See you.